Hello everybody, Large here with another Fix It video for you, and here's an old classic for you. This is a lovely old 1970s radio. It's a Grundig Melody Boy 600, and I've previously repaired this one not too long ago. It came to me as completely dead on mains. It was working on battery, but the customer wanted it to work on mains, and I checked it out and the mains transformer had failed. So luckily I've had loads of old mains adapters over the years, found one with the right output voltage, took the transformer out of that. It just happened to fit perfectly into the place where the transformer goes. Put that in and it worked fine, and it's been working fine ever since. The only thing that ever was wrong with it is it lost the little knob on the top of the telescopic area for the FM, but managed to find a little spindle and solder that one basically on, or fill this up with solder and get it on. So it's got a rather unusual knurled knob on the top of the antenna there. But the customer says it was working fine one minute and the next minute just sort of went quiet. And I said, what do you mean quiet? He said, it's not working on anything. So I said, it's completely dead. He said, oh no, it's there, something's working, but it's quiet. So let's just plug it in and see what's happening. Mains on, power on. I can hear a hum. Can you hear a hum? Yep, should be able to hear a hum. Let's try, we're in medium wave, long wave, oh, FM. Huh. So FM seems to be working. I haven't really fully tested it out, but I would guess FM is working okay. He did say that he took it apart to have a look in case anything had broken, because it had been knocked off a shelf at one stage, and ever since then he hasn't been able to turn the volume down. The reason is he hasn't located the slider into the knob. You can turn it up but you can't turn it down, you have to get a screwdriver in there. But he listens to it mainly on long wave for Radio 4, as long as it lasts, and probably when that goes, because for some reason FM for him on Radio 4 isn't as good, but long wave it seems to get there. Let's hope that long wave isn't got rid of, or Radio 4 on long wave isn't got rid of. But as you can hear, all we've got is a hum. So something on the medium wave and long wave, killer short wave, yep, also is dead as well. So we need to get inside and have a look at it. He did give it to me with the screws, so I've got the screws as well, so we can take it apart. So power it off. So these are quite easy to get apart and quite easy to work on. They're actually I think they were actually built with servicing in mind on these. So simply to get into it, you've got two screws underneath here, there and there, and then the thing you have to remember these is you have to take the battery cover off by pressing the little button in and sliding it off, because the whole cabinet comes apart in two, but without the battery cover taken off they can't separate the two. You can take the handle off as well if you need to, but generally speaking you don't. So just lift up the back there. Oh, of course you have to take off the tuning knob, I forgot that. Yeah, so you lift the back up and it will start to come apart. But what you then do is you then turn it onto its back and you tip it up from the front and take the top away like that. That's how you get it apart. And there's the old transformer that I replaced some time ago. Okay, now for simplicity's sake, I think rather than, because the mains transformer is bulky, gets in the way with the wires and that, I'm going to disconnect the AC side of things and just run it off DC off my power supply. I think that'll be safest. So the simplest way of doing that on this is to take the transformer out and just disconnect the 2 wires to the board from the transformer. So let's just ditch that. They should be just tacked on there really, as I seem to remember when I put it together. Yeah, there you go. So that's the transformer, the high voltage bit, high voltage mains, out of the way. A little bit of spray there, get rid of that. And then we can get into the main board, and the main board is again quite easy to get into on this, effectively the board is held in place by 2 lugs on the top here, or on one side of it here, and 2 clips on the other side. So all you've got to do effectively to get this apart is to get hold of this top part with the dial, pull these clips out a little bit, and then slide it sideways a little bit to take the lugs out of there. Right, so you've got that out, and then with a pair of pliers just get hold of the negative side of the battery and slide it up, and that then releases the whole of the back cabinet out of the way. So you've now got access to the circuit board, quite clearly the circuit board. The components on the other hand are mainly hidden behind the dial. Again, that's easily removable. So what you need to do there is to disconnect the cursor from the dial cord without cutting and breaking the dial cord. And again, let me get a close-up on this one so you can see on here. So what you do on here, you've got the dial cord goes along here and is in 2 little slots there and hooked over this little hook here. And the best way of doing it is to just flip up this one at the end like so, just gently, and then unflip it over the little hook and then flip it out at the end. So that then releases the cursor. That's dead easy. The bottom bit you don't need to disconnect, that's just in a little nylon thing to keep it flat down the bottom. And then the trickier bit is getting this whole assembly off of here, because you've got 2 clips in here, one in there, and 2 the other side. And I've always found this to be the hardest thing on earth to get out. But basically, if you put a screwdriver in this little slot, let me take that up there out of the way. There it is, that's much there. Put the screwdriver in the little slot and push it in and twist it slightly, but being very careful not to break things. And it usually does pop up. So you're pushing in to release the clip. There you go. You can see that there. And then do the same again, that one. So you're pushing the screwdriver in and then flipping it up. It's not, as I said, this is not the easiest one of them to do, and occasionally you can get into this bit where it just literally will not come apart. You've got to push hard on that, but you've got to be careful you don't put too much pressure, because you can snap the circuit board. There are clips at the other end, but they're bigger, so these are the easier clips if there is such a thing as an easy clip. And you can also get a screwdriver in there. I remember now, I need a little flat bladed screwdriver and get into that slot there. Come on, nearly there. I think this is, it's been in and out a number of times over the years probably. It's nearly there. Not coming. Why isn't that coming out? Sure, I got this one. There it is. There it is. So it's just 2 clips there, and then you've got 2 clips at the other end, like so, and that whole dial assembly comes off. You can now get at the whole of the circuit board, all the components, etc. quite easily. Now you may also find, as I've done in the past with these, is this big speaker is a bit wieldy to floating around the bench while you're flipping the board over. Just untag it and solder it onto another one, or think there's a headphone socket on this as well. Yes, there is, but it's probably just as easy just to tag it onto another little speaker, and that's what I tend to do with these things. It doesn't need to be a massively big speaker. Find my spare speakers. There we are. One little speaker will do. Everything's falling down today. It really is. Let's just sit that there for a minute. Get the old soldering iron. I think I need some fresh solder on these blobs here. One there, and then just unsolder the speakers. Probably me or somebody else has worked on this in the past and unsolder this, because it looks fairly fresh, those wires. I can't remember what else I'm pretty sure over the years I've worked on this before, this radio. It belongs to an old friend. Magnets. Blessing and a curse, magnets. Oh. I should have held on to it with something. Anyway, there we are. So we can safely keep the old cabinet bits and pieces safely out of the way. There we are. So the first thing we need to do is to get into a circuit manual for this, and so a bit of pre-preparation. I did manage to find my old manuals for this, not the paper ones, the electronic ones. FM seems to be working, so probably this side of things is okay. Audio output is working because we can hear it, that side is working. The transformer mains was working. So what we need to do is to concentrate on the AM side of things. So the FM side of things comes in here, feeds down through this switch here and into there. So as the FM is working, that would tend to indicate that the IF side of things is also working, doesn't it? So it's the AM side of things. Where's the UKW? Yeah, the switch arrangement there, the UKW, which is that one. I'll have to look at that, but it's always with these a little bit difficult working out where the switches are. But if you have a look, you can see here it gives a little table, lines 1, 2, 3 going down and columns A, B, C, D going up. So if you want to know where, say for instance, this switch here is K3, yeah, it's K3, 2, 1 there. So K is this one here, so that's the long wave switch. Yep. So that one and that, I think you've got kilowatt there, but FM isn't. FM's connected through that switch, through that resistor there. So that resistor must be okay, because the signal's obviously passing through. I think we need to concentrate something around here, T3, which is that the local oscillator? I think it is, yes. Yes, that's a local oscillator, and that'll be, these switches will change these components here to change the value of the, or the frequency of the local oscillator. So I think we need to have a look at T3. Now the only voltage we've got here is 1.2 volt across there, so that's ground. Not quite ground, is it? Nearly ground. Yeah, that's chassis. So that is ground. 1.2 volts to the emitter. So that, for this transistor to turn on, that's going to be probably 2 volts, 2 or 3 volts, and then the collector is going to go up yeah, so we're going to have a higher supply voltage on the collector. So let's see if we can find TR3. Let me open another instance of this manual, and then we can have a look at the circuit board. So we're looking at T3. Let's have a look. Where's T3? Oh, there it is there. T3, T4, T5. Let's zoom in a little bit more on that. And we're on the looking at the printed circuit side of things. So let's turn it over. Right. So on the circuit diagram, zoom in to T3. And we have a little look around here. Anything that sort of stands out on that circuit. If you see something, shout out. Oh, I can see something there. See where it says C34? There's a little bit of print there that stops. And it's right, it's to the left of T3. So if we go on here, yeah, we can see there's that little bit of print. So I'm guessing those three are the transistor components. Let's go back onto the diagram again. Yes, we've got one that goes all the way across, one above and one below. So again, I'm comparing it, I can see both, but you can only see one. So that there is the transistor. That was a little bit of solder on that. Bits and pieces everywhere. Look, blobs, things have been unsoldered in the past. That doesn't look like it's ever been touched. So let's get our meter. And we'll put the meter on the negative side of the battery. We'll get our supply turned on. We'll set that for 6.5, 7 volts I think is the input, isn't it? 6 volts, yeah. Output is on. Just touching the volume control there. Okay, let's go back to the close-up. So, looking at the board layout, we've got sunlight coming in which is making the picture flicker, so apologies about that. So the base of T3 is that one there. Oh, we're on DC, aren't we? I'm just better to check. I sometimes leave it on ohms. So we've got 0.3 on the base. And the emitter, it should be 0. It's 0.3 on the emitter as well. Oh. Collector, 0.6. 6 rather, 6 volts. I think we ought to have a waveform there, but those voltages, as it says on the circuit diagram, didn't it? We go back to the circuit a minute. So on the emitter we should have 1.2 volts. And according to that's the middle pin. The emitter is the middle one. That's that one. And we got 0.35, 0.31, same as the emitter. The base rather. So base, emitter, collector. Yeah. Do you know what I suspect? I suspect a short circuit transistor. Why don't we check it? Let's stick the meter on ohms. So go between ground and the emitter. We've got that 1K, and then to the base 1K. Is that the same? Yeah. And the collector 800 ohms. It's odd that we've got 1K to ground. I thought ground was the same as the emitter. Let me just have another look at the diagram. I may be missing something vital there. Oh yeah, got 1.2K, look, of course, in the emitter. No wonder. So if we're reading 1.2K to the emitter and 1.2K to the base, and there's a 5.6K up here, I think we've got a short circuit transistor. Let's go directly across that transistor. And we've got 0.01, yeah, 0.01. I think we have a faulty transistor here. Let's take this transistor out. So we've identified the 3 connections. Get the old desoldering tool, desoldering pump onto it. There we go. We are powered off, aren't we? We've disconnected power. So also close the blinds because it's now bright sunshine outside and we can't see what we're doing. With too much sunlight, it washes out the camera. So I think we've now released the legs. So that's the transistor there. Get my tweezers. Well, they're not tweezers, they're forceps, I think they're called. Get hold of that. Give it a little wiggle and the transistor comes out. Okie dokie, let's have a look. There it is, and it's a BF241. You can just see that on camera, BF241. Let's put it down here on the bench and perhaps hold it down with a bit of Captain tape. There we are, I've just got a bit handy there already. There we go. There we go. So let's see. So that's base down here, emitter in the middle. It's not holding still. Meter slipping off. Yep, that is definitely short circuit. Base to collector, nothing. Reverse, emitter to base. Yep. Base to collector. High resistance changing. We have a faulty transistor indeed. So let's see. What do we say? I can't remember what we said it was. A BF241. So let me see if I can find one in my selection of transistors. If not, I'll have a look and see if I can find an equivalent for it. Right, well, I've had a look through all my transistors in my little box marked BF transistors. Had this little set of boxes for ages, and then loads of transistors, all different sorts and types, and I can't find a BF241. Here's my Jaeger Electronic 93 comparison book, which I still find invariably useful. And the BF241, if we have a look on here, is a silicon NPN for the use within AM and FM circuitry up to 400 megahertz. and equivalent to that is a BF255. Well, I've had a look through, as I said, all my transistors, and I haven't got a 255, but I've got plenty of BF115s, which are a transistor. I'm pretty sure I've used that in the past as equivalents for this. So if we have a look at a BF115, and see here, and the BF115 is used for AM FM up to 230 megahertz, but it should be the same. That comes out also as a BF255, the same equivalent as a BF241, it's a BF255. So for 255 is equivalent to a 241, and a 115 is equivalent to a 255. A BF115 should do the job. Whew. Glad we got through that. Okay, I've written it all down here on my little notepad. So there's the BF241. Equivalent is a BF255. There's the base. The BF115 is a four-legged transistor, base emitter collector, so it's similar sort of layout. BEC, so no twisting of the wires, but we have got a fourth one there, which is a shield. So on these, they were screened. The actual metal can is connected to the fourth pin. So there's base emitter collector on the BF241, and then on this one we've got base emitter collector on that one. So we don't need to worry about the screen, that's not connected to anything, so we can just drop that straight in like so. Squeeze the legs together a little bit. A little bit more. You may have noticed on the legs on this one it's been used before, because I've some of the transistors in my boxes have been used for testing purposes. If they haven't fixed the fault, I've put them back in the box. Why not? There we go. So that's in. That transistor's in. I think we're done. A quick look with the old loop, make sure we're not shorting anything out. That's good. I think there's little bits of solder blob. Sometimes this solder I use is quite old and it tends to spit. Anyway, let's just give it a clean off with some isopropyl. Yeah, that all looks good. Right. Let's apply some power and see how we get on. This is going to be quite a nice quick fix, this. Right. It's now working again on medium wave and long wave. Have a little look at the thing. I can never remember which way around the switches are. So that's long wave. So let's just write that down. Tone switch, long wave, medium wave, UK, FM. Alright, yeah. Alright, I'm just going to go back to my wide cam, turn the lights off, open up the curtains. See what I mean about the sunshine? Oh, it's a bit bright, isn't it? Now we should be about yeah. That's long wave, radio 4. That's what the customer wants. We fixed it. Yay! Now, I haven't got a medium wave, I haven't got a long wave transmitter, but I have got a medium wave transmitter which I can bring here and apply some input sound to it. Right. So what I'm going to do is I'm going to try my little transmitter, play some YouTube music through it, turn it on. Oop. Pull the power off. There's my YouTube music. So it's definitely working on medium wave. Try these little cheap AM transmitters in the box, just with batteries, that's why it's so big. Anyway, it's working fine on that. If I put the lights back on, you'll see. Oh no, not so much interference as I thought on medium wave, but anyway, it's working on medium wave, but importantly, it's working on long wave. Yep. Okie dokie. So let's put it back together. I think that's the simplest thing to do. Let's close the old blind down because it just whites out. It's lovely having the sunshine. And then we reassemble the display. So remember, on the display we've got these two little lugs on this side and two clips on this side, so we have to put these ones in first into these ones, but they've got little bits of tape on, I think that stop vibration. So just align that and get them into those little slots, push the others down, and then wind your tuning dial so that the bit with the spring goes right to the left hand side. Can you see that on the overhead? Yep, so you can see that there. So that puts the dial up this end. That gives you more freedom. Let me just close up on this so you can see this in a bit more detail. So we've cranked it so that the spring is at this end. The manual does give a re-stringing chart if you ever have to break, or you do break the string. So, but get it up to that end. Push this up so the indicator is on 0 on the log in the middle. It's just a guideline. Push it down so that it goes into that first slot. Doesn't click. Then just pull it over the top of the middle one. Hold it with your finger. And then gently pull it down so it drops into there, and just a gentle little squeeze like so. So then you should be able to wind that back so it goes all the way up to 100. What I do is I take it just before you get to the 100 and just before you get to the 0. That's generally right. I mean, you can, if you know exactly where the frequency is, but there's no specific marks for any of these frequencies on the chart, so that just gets it into pretty much the right position. Then we bring the circuit board back over here. Remember, we've got to get these two metal lugs there and there into these slots in the cabinet there. So keeping it pressed up against those at this end, that should now just drop down, and the two little clips at this side clip it back in. And obviously your battery terminal pushes down into that little slot there. And then push that down there, out of the way. And the transformer, which pops in, well, this one does because it's a replacement, pops in there. Sorry, I'm out of shot there again. So transformer, you can see when I replaced this transformer I had to break away a little bit of the plastic there to make this fit. The actual core did, but the plastic bits on the outside didn't. So that should just drop in that position there with the mains lead over there. Now some of you may say, oh, you haven't changed the electrolytics. I'm not going to. They're working. I'm going to leave them alone. They seem to be alright. Generally speaking, with radios of this sort of era in the 70s, they were made with pretty good components. They weren't cheap Chinese equivalents. This is made in Germany. And you know what German engineering is like. It's very good. Don't know why I've adopted a funny accent there, but I did. Apologies to anybody that got us offended by that funny accent. It wasn't meant to be nasty, it was just my humour. And then we solder on the wires to the transformer. Pop the transformer down, out of the way of that capacitor. It pushes in place, and then the wire comes down here in the little tags, which is basically the cable grip, if you like. And the last thing we do is we solder the wires back on the speaker terminals. Two. And then the top of the radio goes over the holes like so. But before you do, yeah, that's what my friend forgot to do. If you slide the volume control down to that end and the knob that end as well before you drop it in, it should engage, and then you just need to just jiggle the transformer back into place, and it drops in like so. So the mains lead is held in place, but it's held in place there, but there's a little slot where it goes in when you put the battery component back in. Battery cover back in, slide it across, just clicks in place. So we're as good as ready to test. Switch it to mains, turn it on. Refit the tuning knob. So long wave is this one, so 200 meters, bang in the middle.
Increased by 0.5 percentage point. Economists have predicted growth of just 0.1%.
Excellent.
The Shadow Chancellor, Mel Strife, said there was still a long way.
It's all working. So, hope you've enjoyed this little radio repair, a little quick one. Managed to jump on the transistor because it was right where the two signals would have got together, AM and FM, going through that one. FM was okay because it was bypassed by the switch. AM because it had to go through that transistor, which is the local oscillator. Didn't even need to get the scope out. Normally we got a local oscillator failure, you have to get the scope out and see if it's working or not, but obviously it is. So, thanks very much for watching. See you on the next video.